So I wanted to share a little thing. So I'm doing this project 3, that is writing a kernel from scratch with Carnegie Mellon University's operating system course. So these are projects given to master how to build a kernel from scratch, especially for the platform x86, as this is the most prevalent and also a lot of documentation is available for this. So I picked up this system. Okay, so there are a lot of things to learn along the way. So hardware primitives, and then we have device drivers and interrupt handlers, context switching and scheduling. So we need to implement these things, and system calls, building and loading user programs, and also the programming environment. And then they have given some hints, especially for code organization, debugging and checkpoints. So what I did is, so I would like to implement according to the instruction given in this PDF, but I want a more dynamic path, I mean problem oriented. So you give me instructions for what is there in a section and what I must build, and what are some extension possibilities, especially for real-time medical software systems, a more direct problem oriented approach for this. Okay, so here is something that you can get out. Core kernel phases. So first of all, the foundation, you need to set up some hardware stuffs, so exception handlers, GDT, IDT, etc., and paging and direct map, physical frame allocator using bitmap or stack, and also some user programs. So for checkpoint 1, get task ID system call, and then idle and init user program. And then we have multitasking. So phase 1, I need to implement primitive scheduling and context switch. So these are some modules. Then we have the checkpoint 2, and then we have memory management and exceptions. So we'll implement demand paging, process kill, and stack growth. So page fault handler, legal access, illegal access. So these are my modules that I need to take care of. And then system call, that is new pages. So it will allocate new page with this algorithm, and also vanish and wait. Then device drivers and system calls, read line, sleep yield, hardening and testing, extensions for real-time medical software, so hard real-time scheduling, so I will implement this one. Then memory safety and isolation, fault recovery and logging. I hope you get the idea if you have a little bit of familiarity. Device driver safety and safe mode boot. Then problem oriented approach, direct and dynamic, backward from working software. So step 1 is what do you want to see running first. Okay, so single user thread friends, hello from user mode, what breaks first, real-time extension. Want to make your medically relevant, then I recommend starting with task deadline monitoring. Okay, so this will be my extension module. Okay, so then he's asking for helping directly. So I hope you get the idea. So that's something that helps, especially for people like who wants a more backward strategy or problem oriented approach, I guess.